This is lesson 2 from cycle 3 of advanced functions. In this one, we're going to look at writing the equation from a graph of a polynomial and what is a family of polynomials. So factored form of a polynomial, it probably shows it here. This would be factored form. So if we're using y and x, then we obviously have our brackets for the factors, a1, a2, a3. Those are just our different zeros. So you're used to that, again, from previous math courses. And k is just going to be, we're going to use the letter a actually, but k is our leading coefficient, our stretch factor. So let's look at some specifics. If I wanted to come up with an equation for this first graph in part A, then I can see that it's got zeros at -2 and +1. So I could start by writing y equals, and again, I'm going to use a instead of k, and then I'm going to plug in the zeros. So the zero is, one of the zeros is -2. So it's x minus -2, which of course is going to simplify to a plus x, and normally I just do that in my head, but I want to show it this time. The other other factor would be x minus 1. And again, a is our stretch factor, and it's our vertical stretch, right? So if I simplify that, simplify the signs, again, I would normally just go straight to this. This is what we've got. This is called a family of functions. And the reason why is because it's a whole bunch of functions with similar characteristics, but there's differences between them, just like in a real function, or a real family. A real family's got people who have similarities, but they're not identical, they've got differences. So that's a good way to think about it. If I want to find a specific member of the family, then I need to know what the a value is. So this graph is of a specific family member. With an a there, then it could be lots of different versions. But if I find a specific value of a, then I can have a specific member of the family. So if I want to know what the equation is for this family member, I need to find another point on the graph, substitute it in, and find out what a is. So on this graph, we can see the y-intercept. It doesn't have to be a y-intercept, but that's often an easy one to read. We can see the y-intercept is 0, -4, right, as an ordered pair. That's the ordered pair for the y-intercept. So if I plug in 0 for x everywhere and -4 for y, I get this. And then I simplify it. And I keep simplifying it. 2 times -1 is -2. I'm going to write that in front of the a, because when we've got variables and numbers together, the numbers should come first. And then I'm going to start solving this equation. I'm going to divide both sides by -2. And I get a equals 2. So now I know the a value, and I can write the actual equation. Y equals 2 times x plus 2 times x minus 1. And that's our equation of this particular polynomial in factored form. Let's do it again for this one. Y equals a times x plus 1, and it's plus 1 because we've got a 0 of -1. We got another 0 of 1.25, so it'll be x minus 1.25. And we've got another y-intercept. This time it's 0 and -6.25. So we can substitute that in, and we can find out what a is. Sorry, not x. 0 plus 1 0 minus 1.25. And doing a little bit of simplification, I get negative 1.25a. And again, I need to isolate a. And it turns out that negative 1.25 goes into negative 6.25 4 times. So the equation of this particular quadratic, not a quadratic, polynomial is 4 times x plus 1 times x minus 1.25. And again, this is a specific function for a specific polynomial, but when we've left a in here and not put a particular stretch factor in, then we're talking about the whole family. So there's just other ways that we can come at this, like this example. Zeros of a family functions are 2 and 3. So instead of giving us the graph, they just tell us what the x-intercepts are. Determine the equation of the family. Okay, y equals a times x minus 2 times x plus 3. Write equations for two functions that belong to this family. So we're allowed to make up anything we want. So all we have to do is pick some values of a and stick them in there. So I could do y equals 5 times x minus 2. Or I could do 6 times x minus 2 times x plus 3. I can pick anything I want. I could pick negative values of a. I could pick decimals. It doesn't matter. Every different a value will give me a different family of member of the family of equations. Determine an equation for the member that passes through 1, 4. Okay, this is the point we've been given, just like we did in a previous example. We have to plug that in for x and y. That makes y 4. And I'm going to calculate what a is. This time it's not an x-intercept, so I have to put 1 in for x. And I just have to be aware of that when I simplify things. So it turns out I've got a negative 4 in front of the a this time. When I divide it out, a turns out to be negative 1. And so the equation for that particular member from part C is negative 1, or I could even just write negative without the 1, the negative's assumed. X minus 2, x plus 3. Here's a more complicated looking one, but we're going to use the exact same approach. Irrational zeros just mean that we're going to have some square roots in there, but we'll do the same thing. We're given 4 zeros, positive 1 and negative 1, or plus or minus 1 means 2 different zeros, and 2 plus root 3 and 2 minus root 3 is the other one. So literally, let's list them. So the zeros are negative 1, positive 1, 2 plus root 3, and 2 minus root 3. And so each one of those will be a factor. So y equals a times x plus 1, x minus 1, let's say x minus 2 plus root 3. Let's keep brackets to show where things are coming from. And then x minus brackets, again, 2 minus root 3. When I take the brackets off, the first two I've already done, but when I take those inner brackets off, what I get is x minus 2 minus root 3 and x minus 2 plus root 3, respectively, because this minus sign turns this negative and it changes this sign, and that's how we get the signs we get. And again, this becomes negative. This actually becomes positive when we combine the two negative signs. That's our answer for the whole family. And then to find an equation for a specific family member who passes through the point 218, again, we just plug that in for x and y. equals a times 2 plus 1. I'm going to put 2 in everywhere for x. 2 minus 1, 2 minus 2 minus root 3, 2 minus 2 plus root 3. Obviously, there's going to be simplifying going on inside the brackets. These cancel out, leaving simply a negative root 3. These cancel out, leaving positive root 3. When I multiply 3 times 1, that's just equal to 3. When I multiply root 3 times root 3, just equals 3. The square root sign goes away. And it'll still have a minus sign in front. So this becomes negative root 3 when I multiply them out. And I'm just highlighting to show where things come from and what they're ending up as. So final simplification before I solve is negative 9a. And then I divide both sides by negative 9. And so a ends up equaling negative 2. And then the whole equation ends up being y equals negative 2, and then go back to having x's in the equation. That would be the equation for one specific member. In fact, it's the one that goes through the point 218.